Okay, well, let's go ahead and take a look at the quiz that you took. Okay, there was 13 questions, and there were some open-ended as well as some multiple choice. So let's take a glance at the correct answers here, and let's see what you got wrong and why. Some of you kind of knew what you got wrong. Hopefully on Sunday evening, you went to Blackboard to go and look at what you got wrong and why you got it wrong. If not, maybe you'll take a glance, look at it here on the video. Okay? So first question. First question here says, how much time does it take for a car to travel the distance of 2 kilometers while going at a speed of 80 meters per second? Okay, first step is I'm going to label what I'm looking for, question mark time. I'm also going to label what they gave me. They gave me the distance here, and they also gave me some kind of speed number. And remember, if it's a velocity, it's okay because speed and velocity have the same equation. But almost everybody got this question wrong, okay? Did you notice the tricky part here that was here on purpose to throw you off? Did you notice that this is in kilometers and this is meters per second? Before you can do anything, first thing you have to do is convert the kilometers. So let's King Henry this. King Henry drinks utterly delicious chocolate milk, okay? And you need to go to meters. Why are you converting this number? Because this number has 1 SI unit, this number has 2 SI units. I would never ask you to do 2 SI units. I'm only going to ask you to do 1 SI unit. So from here to here, 1, 2, 3 places. The decimal needs to move 3 places to the right. So instead of 2.0, it's going to become 1, 2, 3. The new number becomes 2,000 meters. 2,000 meters. I'm looking for the t. Speed equals d over t. Or I'm going to put this into the triangle. D is at the top of the division, then t, and then speed. I'm looking for t. T equals d over speed, or 2,000 divided by 80. Your answer is going to be in seconds. Okay? I will take a picture of the answer key and post that as well if that's more helpful. But that is the correct, that's how you get the correct answer. And that's why you may have missed it. You may not. You may have caught it and had no problem with that. But no, it needs to be converted first. Let's go ahead and look at question number 2. While traveling along a highway east, okay, there's a direction. A driver slows from 25 meters per second to 15 meters per second in 90 seconds. Okay, so meters per second, 90 seconds. It looks like all my units match up. What is the automobile's acceleration? Okay, not a problem. I'm looking for the acceleration, question mark A. If this is what I'm driving, initially, VI, this is my VF, and this is my T. Okay, so here's all my variables. You could, number 1, come over here and put A, question mark D, not given, T, 90, VI, 25, and VF of 15. But also, before I go any further, I'm actually looking for acceleration. Remember, every number could possibly have a negative value except for T. So this could be a negative. I need us to start thinking before we answer the questions. Would this be a negative or positive number? What am I physically doing? What is the driver doing? What is the car doing? It's going from one speed to another speed. Is it going faster or slower? It's going slower. And if you're going to go slower with acceleration, that is a negative value. Okay? And slowing down is a negative value. You ready? So already I know that I should probably see something that's a negative. Let's go ahead, and if you wanted to, you may have used the flow chart. In the flow chart, it asks you, was D ever used? Look at this. No, it was not. There's an X here. So in this case then, using the flow chart, I'm going to go ahead. A equals VF minus VI over T. Remember though, there's always more than one way to do your math. I don't mind how, especially on the homework, but I need to see it. Okay, so let's look at this right here. We're looking for acceleration. I do not have to algebraically change it. It's going to stay the way it is. 15 take away 25 divided by 90 equals blank meters per second square. What kind of an answer am I going to have? I'm going to have a negative answer. Negative 0.11. Okay? Again, if you are still kind of struggling, you should probably look over this and then go ahead and practice it. All right? Have your calculator with you right now while you're going through this with me, and do that. The next one is matching. On the question here, this one, a lot of students got part of it wrong. It says some of the answer choices may be used more than once, some may not be used at all. Well, let's look at what we're going to match up. Speed, velocity, acceleration, or none of these. Here are the units that they gave me. m/s squared, acceleration. Kilometers per hour. What kind of units are those? Those are speed units. Why speed? Because there is no direction, so it cannot be velocity. Miles per hour per second. Let me say it this way. Distance/time/time. There's two times, just like there's two times here. It's acceleration. Miles per hour with no direction, speed. Many students miss part of those. Okay, let's keep going. The next one here says here that Susie rides her tricycle from point A to point B, A to B, which is 12 meters to the right. Then she turns around and rides her tricycle from point B to point C, which is 4 meters. What is her distance? When we see the word distance, we think of the word add. Why? Because we need to add up all of the distances that object traveled. This Susie, she traveled 12 meters, and then she traveled 4. So 12 plus 4 is 16 meters is her total distance. But over here, the next question was, well, what is her displacement? Displacement is from the ending to the start in a straight line. What is this distance right here that she traveled? Well, if this whole line A to B is 12 and B to C is 4, then how far is from here to here? Well, we can do that by subtracting them, right? 12 take away 4 equals 8 meters is her displacement. Okay, let's keep going. It says here that a CHS student is running away from Principal Belcher after pouring slime on her truck 38 meters per second through the parking lot. After 8 seconds time, the student outran her and begins to decelerate to negative 5.5 meters per second square. How far did the student run? How far did the student go? So we're looking for distance. Let me come over here and let me label all my stuff. We're looking for how far, question mark distance. Oops, let me move this a little closer. They gave me T, which is 8 seconds. They gave me A, and they gave me the VI. If this is me, the first step that I'm going to do when it comes to any kind of kinematic equation is write down my 5 variables. A, D, T, VI, VF. A is negative 5.5. D is my question mark. T is 8 seconds. VI is 38. VF was not given to me. Using the flow chart from your notes, was D ever discussed or used in this equation? Yes, it's my unknown. Was T ever used? Yes. It tells me that my equation that I should use is D equals VI times T plus 1/2 AT squared is my equation. Remember what I do. I go back and I double check it. My flow chart is not always 100% accurate. Do I have the D? My unknown. VI, check. T, check. 1/2, check. A, check. T, check. Not only am I going to use this equation, but I'm going to use it the way it is, and I'm not going to rearrange or change anything on it. So let's go ahead and do that. VI is 38. Multiply it by 8 plus, I'm changing the 1/2 to 0.5 times negative 5.5. Multiply that by 8 squared. Okay, so here's my equation that I'm going to use. I plugged in all of variables over here, all the numbers. I'm going to find my answer in meters. Okay. Please go ahead and work out the math. That way you can actually get the answer, and then maybe you can remember whether or not you put that on there. Hopefully you double checked your blackboard to see the answers. To the right is a graph of an object's motion. Which best interpretation is this? Or what words right here best interpretation interprets this graph? First thing is, what am I going to do with the graph? I'm going to label it. This is a DT graph. And what is a DT graph with a line that's a nice pretty slope like this? That is a direct relationship line. It means that it is moving away from the origin at a constant speed. Where did I get that from? Remember that worksheet that we did, DT and VT graphs? That's where I got it from. Now that I went ahead and wrote everything down and I brain dumped all over this, let's see which ABCD, the object is moving at a constant speed away from start A. That is a correct answer right there. Hopefully that's what you marked. Next one. The next one is another graph. What is the first step that we do before we do any graphs? We go and read the X and Y axis. This is a VT graph. What does a VT graph tell you? A VT graph tells you the acceleration of an object. What does a DT graph tell you? It tells you the speed of the object. Okay, now that I have this, what is the next step I do? Do not even look at the questions. You go over here and you start labeling this VT graph. That's what you do next. So let me go ahead and get out my worksheet. Right, looks like this. And let's label it. If I have a line over here, it is accelerating. This line is accelerating. The flat line means that it is moving away from the origin at a constant speed. And what does this line over here mean? This line over here means that it is slowing down or it is decelerating. I went ahead and look, I labeled everything. Now let's go ahead and go to the questions. What is the car doing between line A to B? From A to B, it is moving away at a constant speed. What's going on between line C to D? It is slowing down. What about from the start to point A? It is accelerating. What about from point B to point C? It is also accelerating. But do you see how I first started off? I labeled what type of graph I have, and then the next step was for me to go ahead and label the actual graph. Okay, now I can answer my questions with no doubt at all. Let's keep looking at the next one. Next one here is a helicopter is at rest. If you are at rest, then the VI is 0. And don't forget, in physics, words have number value. And takes off straight upwards at an acceleration of 148 meters per second square. A. And has a final velocity of 67. V sub F. During this time of acceleration, what distance is the helicopter above the ground? Question mark D. First step. A, D, T, VI, VF. A is 148. D is question. T, X. VI, 0. VF, 67. I'm going to go ahead and label all my stuff, my variables. Using that flow chart, was D ever used or discussed in the equation? Yes. Was T ever used or discussed? No. Look, wasn't even given. So using the flow chart, it tells me to go ahead and use this equation. A equals VF squared minus VI squared over 2 times D. That's what it's telling me. Go ahead, rearrange this or algebraically solve it, and we're going to look for D. But before I go further, let me double check to see if my flow chart is like throwing me off or not. Do I have the A? Check. Do I have the VF? Check. Do I have the VI? Check. The 2? Check. The D is my question mark. Could I use this equation? Yes, I could. I can use this equation, rearrange it, and solve for the distance. So let's go ahead. I'm going to put 148 equals 67 squared minus 0 squared over 2 times D. Right? Subtracting 0 squared is not going to do anything, so I'm going to go ahead and X that out. I can even X out the subtraction part. Go ahead and square the 67. This 2 is being multiplied by the D, okay? So what I do is I would multiply by 2 on this side to cancel the 2 out. Multiply 2 on this side. So 148 times 2, I would multiply that. D, I need to get to the top, so now I would multiply D on this side, multiply D on this side, divide those numbers, and cancel. Again, hopefully you see this is why I use my triangle. Look at this, all this algebra steps having to go on. I would like to just go ahead and simplify it using the triangle, but it's up to you, your choice. But here's how you solve it, okay? And hopefully you got an answer of, if I remember off the top of my head, it should be like 15.16 or something like that, give or take, meters. So that's how you solve this equation. Turn the page. Here we go. Now they gave us this DT graph and we had to find the VT graph that matches it. First thing I'm going to do is I'm going to label this DT. What is the next thing I'm going to do? Hopefully you have, again, your worksheet that looks like this, and I'm going to label it. This line right here means to speed up, constant speed away, and this line means to slow down. Okay? Now that I labeled it, let's go ahead and find the VT that matches it. Well, first thing, this speeding up. Well, what line on a VT graph means to speed up? This upward slope, a direct relationship line. So first thing is, I can cancel anything that does not have a direct relationship line to start off with. This doesn't. This is a downward, so no. And this is a flat one, no. Look at that. By at least looking at that, I can eliminate all three of them. That is my correct answer. Okay? Let's keep going on. First thing, what do? Label it. VT. Tell me what's going on. On a VT graph, when I have a line below the x-axis, that means that it's moving to the origin at a constant speed. What's the next line? It is above the x-axis. Above the x-axis is away, at a constant speed. And this one is also away at a constant speed. Now I'm going to pause for a moment so that way you can stop and look. Both of those lines are above the x-axis, but this one's further from this one. What does that mean? That means that this is away, moving further away, and then all of a sudden it's closer. It's still moving away, but it's closer. Okay, first one, moving to the origin at a constant speed. Let's go find our DT graph. Constant speed is this one. Moving towards the origin is an upward proportional direct relationship graph. Okay, so first thing, it can't be this one because this is a downward line. So that's out. This one, maybe. This one is a downward curve, so that's out. This is a downward line. That's out. That's my only one. Look at that. I was able to go ahead and eliminate. Pretty nice. Pretty nice. Let's keep going. I'm stopping and thinking for a moment. Below the x-axis is to the origin and away from the origin. To the origin, away from the origin. Yep. Okay. Making sure. This one is to the origin. And then look, here's the origin right here. And look at it moving away and away. Let's keep going. Look at the DT graph over here. Which of the following movements describes it? First thing, it told you it was a DT graph, but you can look at the y and the x-axis and you can say DT. Before I look at my answer choices, hopefully we have that paper in front of us that looks like this. We can go ahead and label it, and we can say that it's going to speed up. We can say away at a constant speed. We can say rest. And then we can say away from the origin at a constant speed. Okay, so I labeled it. Now that I labeled it, let's come over here, and the first word that we wrote is speeding up. Constant speed, at rest, speeding up, slowing down. So at this moment, it cannot be this, it can't be this, it can't be this. It has to be this or this one. Away at a constant speed. Speeding up, constant speed away, at rest. This is the only one that it can be. All right, let's keep going. And the next question, what is the object speed using this graph at T5? This was a highly missed question now. Here is T5. Let's go ahead and let's go up this way. Remember, I went ahead and labeled it. What is my graph doing? It's at rest. How fast are you moving when you're at rest? 0. That's the correct answer. 0. Okay, let's keep going. Almost done. That was it. Okay, so there's all the answers. I'm going to take a picture, post those as well. Please take a glance. Hopefully it would help you out a little bit. I hope it helps you out a lot. Okay, don't forget we have a test as well. Please have everything in front of you when you're taking your test. Okay, it is a time test, so be cautious on that, but at the same time, please make sure you're confident when you answer that question before you move on. Okay, bye-bye.